Let's look at the solutions to the questions on page 31 of the handout called MMM Limits. This is number 28 through 39 on page 31 of that document. That's page 4 of the document. And we talked about doing these problems after we looked at limits as they approach infinity. And we talked about that being what is happening to the right or left-hand end, which is asking about horizontal asymptotes and whether the function has a horizontal asymptote. So let's look at question number 28. For the limit as x approaches infinity of 6, I think the easiest way to picture that is maybe to think about a graph. Now you have to be patient while I'm learning how to use this little stylus. It's not very good, not very easy to use. If we got a horizontal line at 6, and I approach infinity, that's what's happening at the right-hand end. So I want to think about what's happening down here at this end as I approach infinity. And that's going to just stay 6. So the answer is equals 6. I also use a graph to picture this next one on number 29. If we think about what the graph of that would look like. Let's see if I can draw a better graph this time. On the basic xy axis, I want to think about the function negative 2x plus 11. We know that's a line, intercept at 11, negative slope of 2, so we know we've got something generally of this shape. Think about what's happening as it approaches infinity. That means, again, to look at the right-hand end, what's happening as we get larger and larger on the graph. This is going to keep getting smaller. Thinking about plugging in large numbers into the place of x, we'd get really big negative numbers. So that answer is going to be equals negative infinity. Number 30. Think about what this polynomial looks like. This is a 4th degree polynomial. So we know because it's a positive even exponent, then we know that that's going to end up with both the end points starting up or both going down. And since this is a positive value on the front end, because that's positive 3, then we know that it's going to end up being starting up and ending up. So our function looks like some amount of wiggling in here for the 4th degree. It's going to end up in this shape. So again, think about what's happening as we approach positive or negative infinity. And so that means I'm headed this way on the graph. Then again, that's going to head to positive infinity for my answer for the limit. Number 31. This one's more like the ones we practiced on last class. If we're approaching positive infinity and we've got the same degree on the numerator that we have in the denominator, so we've got our 2x over 4x, then I know that the x's would divide out and I'm left with the answer 2/4 or 1/2 if you prefer. 32. This time the highest power on the top is not the first term, it's the last term. Highest power on the bottom here. So we would end up with a negative 3/2. If you want to double check that one, if it bothers you because of the negative infinity, stop and think about what would happen if you plugged in a really large negative number into the place of the x. So if we think about what would happen, large negative number right here for x, that would be negative, times the negative that's in front of the 3 would be a positive number on the top. If they take that really large negative number that you plugged in the top and plug it in here on the x, that's going to give you a really large negative number in the denominator as well, the same one. And it's going to end up with negative times 2 is negative. So positive on the top, negative on the bottom, we would still have a negative 3/2 as the answer. Number 33. This is one of those with the higher power on the bottom. So the largest exponent is in the denominator. So we talked about that means that the denominator is going to grow faster than the numerator. So we end up with a limit of 0. 34, another one of the same type. So we've got that higher power on the bottom, larger than the one on the top. Even as we go to negative infinity, you can still picture that what that's going to happen is this is going to be a really large positive number on the bottom and a really large negative number on the top. That's still going to be the bottom's growing faster and I'm going to get an answer of 0 for the limit. Number 35. Here we have one with the higher power on the top this time, so that x to the fourth over x to the third. That means I think about that as, really, if I want to simplify it, you can think of it as 4x over 3. Now think about what happens to that as x approaches infinity. Really large positive number in the numerator. That's going to end up going to positive infinity for the limit. Highest power in the numerator, highest power in the denominator. Simplify that and get negative 5x over 9, which means think about putting in a really large negative number into that x, which means negative 5 times negative, a really large negative, negative 1 billion, and that's going to end up to positive infinity. We did one similar to this last class. We look at the square root of x squared, which is simplified to x. Now I compare the two. X over x is 1. Coefficients end up being 1 over 1, so the limit will go to 1. Similar situation here where I've got the x here, but if you picture what will happen if you plug in a really large negative number, when we plug the negative number inside the square root, that's going to be positive, and the square root of positive number is still going to be positive. But in the numerator, when you plug in a negative 1 billion, then you get negative x over positive x. So we're going to end up with negative 1. So I thought of that by plugging in large negative numbers. That helped me figure that one out. And the last one. Think about what we have here. That's going to end up being x, square root of 3x actually, as the highest power. And so the x squared in the denominator is larger than the x in the numerator. So we end up going to 0 again. So those are the answers for, can get rid of that. All of the problems from 28 to 39 on page 31 of the Master Math Mentor Limits handout.